In this tutorial, we will be discussing the relationship between pressure and volume in gases. This is called Boyle's law. Alright, so in the previous tutorial, we discussed that when the gas pressure is the amount of times a gas particle will hit the side of a container. And so the more times it hits, the higher the pressure is. The less time it hits, the less pressure it is. So that relates to pressure and volume very directly. For instance, here, if we're looking at 4 liters, it has lots of room for the molecules to take its time to hit the container. However, if we decrease that volume to only 2 liters, it doesn't have the particles don't have as much room to move around. And so because of that, the particles are hitting the side of the container more often, therefore increasing the pressure. There is a direct relationship. As the volume decreases, the pressure is going to increase simply because there's not enough room for it to travel, and so therefore the particles are hitting the sides of the container more often. And it just so happens that this relationship is direct. As one goes up, the other one goes down an equal amount when the temperature is constant. So if the pressure is 8 and 2, it's going to be 16. If we increase that volume to 4 liters, the pressure is going to decrease to 4 liters. If we double that again, it's going to be divided in half again. No matter what, in the same container, the volume and the product of the volume and the pressure are going to be the same at a specific temperature. This relates directly to nursing and directly to health. For instance, if we're looking at breathing, as we inhale, the diaphragm contracts and it's actually opening up our lungs, creating a lower pressure in our lungs because there's more room for the gases to move around. Therefore, the air is going to go inside the lungs to fill up that space. As we exhale, the volume in the lungs is then going to decrease, creating a higher pressure, and the air is then going to go out of the lungs and out of the mouth. So as the volume goes up, the pressure goes down. As the volume goes down, the pressure goes up. Alright, so let's do several calculations just for practice. There's a couple key terms I want you to realize. The primary one is of. When you see the word of, that means those two things are going on the same side of the equation. That's a key term. Another thing I want you to pay attention to is the fact that the units have to match up. You can't have millimeters of mercury on one side and atmospheres on the other. If that happens, you have to convert it so that way they have the same units. Alright, so the equation is going to be P1V1 is equal to P2V2. The reality is, it doesn't matter which is the ones and which is the twos. What really matters is what stays together. For instance, Freon was used in refrigeration systems. What is the new volume of an 8-liter sample of Freon at 550 millimeters of mercury? So that means that 8 liters and the 550 stay on the same side of the equation. Is equal to, after its pressure is changed to 220 millimeters of mercury, 2200 millimeters of mercury. And they're wanting to know the new volume. So 8.0 times 550, and then we're going to divide 2200 from both sides to get rid of the millimeters of mercury on the right to be left over with volume. That comes out to be 2.0 liters. I know it's going to be in liters because the millimeters of mercury cancel out, and we're left over with liters. That's another reason why you need to make sure that the units are all matching up. A sample of oxygen gas has a volume of 12 liters at 600 millimeters of mercury. Notice the at, that's the other key term. So it's of or at that stay together. 12.0 liters at 600 millimeters of mercury. What's the new pressure? So we're looking for the new P of if the volume changes to 36.0 liters. So 12.0 times 600 divided by 36.0 liters. 36 cancels out. So the new pressure is going to end up being 200 millimeters of mercury, which is A. Okay, now this is a visual question. For a cylinder containing helium gas, indicate whether cylinder A or cylinder B represents the new volume of the following changes, while the amount of a gas and the temperature of the gas stays constant. So here's the initial. If the pressure decreases, that means that the volume is going to increase. So part 1 is going to be B. Because as one goes up, the other one goes down. So if P goes down, that means V goes up. So if we look at B, or part 2, the pressure increases. That means the volume is going to decrease. So as one goes up, the other one goes down proportionately. If the sample of a helium gas has a volume of 120 milliliters, notice we're dealing with milliliters now instead of liters. That's perfectly fine. The most important part to remember is that the units need to balance out. And a pressure of 850 millimeters of mercury. That of means those two go on the same side of the equation. What is the new volume if the pressure is changed to 425 millimeters of mercury at a constant temperature and amount? So it's 120 times 850 divided by 425. That comes out to be 240 milliliters. Notice the milliliters this time because the millimeters of mercury cancel and we're left over with milliliters. We'll have one more sample. This is another visual. A sample of gas is in a balloon, has a volume of 6.4 liters. So this initial one has 6.4 liters at a pressure of 0.70 atm. At 1.4 atmospheres, atm, what is the new volume, A, B, or C? So let's do the equation. 6.4 liters times 0.70 atm is equal to whatever the volume is times 1.40 atm. So 6.4 times 0.7 divided by 1.4. That comes out to 3.2 liters. That is actually half the amount that we initially had. That means that the balloon is going to be smaller. That means it's going to be A. It might not look like half, but that's our only option that's actually smaller. And that is Boyle's law.